Hello everyone, today we're looking at Unit 6, Lesson 6, right angle word problems. So just continuing to explore primary trig ratios as well as the angle of elevation, angle of depression that we spoke about in the previous lesson. So we'll start with the first question. The top of a lighthouse is 100 meters above sea level. From the top of the lighthouse, the angle of depression of a sailboat at sea level is 52 degrees. Find the distance of the boat from the foot of the lighthouse. Okay, so let's start by drawing a picture to help see this. So we have a lighthouse. Okay, we'll say there's a light at the top of this house. It says the top of the lighthouse is 100 meters above sea level. So let's say that this lighthouse is on the sea. And the top of it is 100 meters above sea level. From the top of the lighthouse, the angle of depression of a sailboat, so we'll put a sailboat in our water, is 52 degrees. Find the distance of the boat from the foot of the lighthouse. So we have to make sure we can draw that angle of depression because it's saying the angle of depression, right? And I just want to make sure that so we can see that this side of the triangle is going to go all the way down. Okay, so when we're talking about our angle of depression, remember it's always made with a horizontal line or this horizon that we draw in ourselves. It's not really something you can see, but that's how the angle is actually made. So this angle of depression to the sea is 52 degrees, which means this angle inside our triangle is also 52 degrees. So it says find the distance of the boat from the foot of the lighthouse. So if we were going to make this a nice triangle like this, we're trying to find that distance there. So let's state what that's going to represent. So let's let X represent the distance of the boat to the lighthouse. Now we'll take a look at what information we've been given to decide which trig ratio we're going to use. So let's just, again, put up at the top because it's always helpful to have there. So, TOA. Okay, so if we label our angle as theta, this is our theta. The side across from our angle is our opposite angle, and the side next to our angle is our adjacent angle, right? Because this is our 90-degree angle here. So if we have O and we have A, that tells me we're going to use TOA. So we'll say the tangent of theta is equal to opposite over adjacent. So we'll plug in the information we have. So the tangent of 52 degrees is equal to 100 over x. We'll put that over 1, and then we'll cross multiply to solve. So we'll have x times the tangent of 52 degrees is equal to 100 times 1, which is 100. And then we'll divide both sides by the tangent of 52 degrees. And we should get that x is equal to 78.1. And I rounded to just one number after the decimal because in this case that is our final answer. I had said in a previous note, don't round to the end, but that is our final answer for this. So the distance of the boat to the lighthouse is 78.1 meters. Let's take a look at another one. So an observer standing 25 meters from the base of a tree notes that the angle of elevation to the top of the tree is 55 degrees. If the observer's eye level is 1.8 meters from the ground, calculate the height of the tree. So we'll draw our tree. We have an observer on the ground over here. It says their eye level, so from here, is going to be 1.8 meters from the ground. So from there to the top of the tree the angle of elevation, which again, we need to make that horizontal line that's parallel to the ground, right? So our angle of elevation is going to be 55 degrees. And it says that the observer is standing 25 meters from the base of the tree, okay? So they want us to calculate the height of the tree. Well, we already know some of the height of the tree because from here to here is also going to be 1.8 meters, just like the height of the observer. So we really need to find the rest of that distance from here to here. So let's let x represent the rest of the height of the tree. And I just want to make that a complete triangle so we know this is our right angle, okay? I'd like you to pause the video and see if you can determine which primary trig ratio you're going to use, and then solve for x and answer the question, what is the height of the tree? So you should have determined that we need to use our tangent ratio because we had our opposite and our adjacent side we were working with. If you subbed into that and cross-multiplied, you should have found that x was equal to 35.7037. Remember, don't round until you're sure that's your final answer. We needed the total height of our tree, so we needed to add the 1.8 to the x value. So we found that the total height of the tree was 37.5 meters. So we'll just wrap it up with a therefore statement. So therefore, the height of the tree is 37.5 meters. We'll look at a few more. Okay, number 3, a tunnel is to be made through a hill from A to C as shown in that diagram below. The angles of elevation to the top of the hill from points on opposite sides of the hill, but on the same level, are 29 degrees and 44 degrees. The top of the hill is 500 meters above the tunnel. Find the length of the tunnel joining points A and C. Okay, so some information they gave us here, right? This angle of elevation is 29 degrees. We have another angle of elevation that's 44 degrees, and the height to the top of the hill is 500 meters. So that's like your altitude. So it says find the length of tunnel from A to C. Well, so far we've only been working with right triangles. So we're really going to think about this question as if we have these two right triangles in here. So A, B, and then we already have a C. So we'll call this D. Okay, and then our other triangle, whoops, our other triangle would be BCD. So from here to here, right? And then this is 500, since I've kind of gone over that. So we need to find the distance across the bottom of both of those. So we'll say that this is X and this is Y. So let's just make sure that we state what those represent. So let's let X represent the distance from A to D. Now we're going to let Y represent the distance from D to C. Okay, and then we'll have to add those together to get our total distance. So let's start. Why don't we start by finding X? Let's find X. Okay, so if we look at X, we have to kind of look at this triangle and determine, well, what information do I have? Is there a primary trig ratio I can use? So if this is my theta, this is the angle they gave us. Well, which sides do we have? We have this side over here. I'm going to change my marker for. Okay, this is our opposite side. And the other side we're working to find, that's our adjacent side. Okay, so if we have opposite and adjacent, we're going to use our tangent ratio, which is opposite over adjacent. So we'll plug in the information we have. Our theta is 29 degrees, our opposite side is 500, and our adjacent side is X. We put that over 1, and we're going to cross multiply to solve. So we'll have x times the tangent of 29 degrees is equal to 500. And then we divide both sides by the tangent of 29. And we should get that x is equal to 902.0239. Okay, so that's finding x. Let's take a look at finding y. So again, if we're finding y, now we're going to look at this triangle over here. This is going to be our new theta. But our sides are essentially the same. That's our opposite side. This side down here would be our adjacent side. So again, we're going to use our tangent ratio. So the tangent of theta is equal to O over A. This time our theta is going to be 44 degrees. Our opposite side is still 500, but now our adjacent side is y. So we'll put that over 1, and then we're going to cross multiply to solve. So we'll divide both sides by the tangent of 44. And we will get that y is equal to 517.7652. So we found x and we found y. We need to now find the total distance, right? Our total distance is going to be equal to x plus y. So x was 902.0239. Remember not to round until your final answer to get the most accurate solution. So if we add those together, we should get 1,419.8. So we can say, therefore, the tunnel is 1,419.8 meters long. All right, let's try one more word problem. So it says, from the top of a 90-meter fire tower, a forest ranger spots a forest fire. The angle of depression from the top of the tower to the fire is 3 degrees. How far away is the fire? Okay, so let's draw our tower. Say that this is our tower here. It's 90 meters tall. There's some fire some distance away. I'm just going to draw fire. Okay, so he spots that fire at an angle of depression. So let's finish our triangle, but then remember, for our angle of depression, we need to draw that horizon, or that horizontal line that's parallel to the ground. So our angle of depression is 3 degrees, which means that this angle here is also 3 degrees. So it says, how far away is the fire? So from that fire tower, they want to know how far away that fire is. So I'd like you to pause the video, take a moment, write that let statement to tell me what x is going to represent, set up your trig ratio, and solve, and finish off the question with a therefore statement. Okay, pause that video and give that a try now. Okay, so there's your solution. Hopefully you recognized that you would use your tangent ratio, and you could find that the fire would be 1,717.3 meters away from the tower. That is all for your note for today.